Hello, my dear students. Today we are going to discuss about the angular velocity of the connecting rod. Now, consider the motion of a connecting rod and a crank as shown in this figure. So, from the geometry of the figure, we can find out the value of CQ. This is the CQ. In this right angle triangle PQC and OQC. The value of CQ is L sine phi in this right angle triangle PQC, and that is equals to R sine theta. The value of the CQ in this right angle triangle OQC, that is equals to R sine theta. And now we can written as L upon R equals to sine theta upon sine phi. The value of L upon R, that it means the length of the connecting rod to the length of the crank. So it is the ratio of both length of connecting rod and crank, that which is represented by N. N is equals to sine theta upon sine phi. So here you can see the sine phi is equals to sine theta upon N. Now the differentiating both the side with respect to time. This equation can be differentiating. Now the differentiation of the sine phi, that is equals to cos phi, and with respect to time, that it means d phi upon dt, that is equals to sine differentiation of the sine theta, that is cos theta and is constant, and d theta upon dt. So now d theta upon dt, that this is equals to the angular velocity of the crank. Then next, this is represented by the angular velocity of the connecting rod d phi upon dt. Now here you can see that since the angular velocity of the connecting rod PC is same as the angular velocity of this point P with respect to C is equals to the d phi upon dt. Therefore, the angular velocity of the connecting rod omega C, that is equals to d phi upon dt. The value of d phi upon dt is substituted from the previous equation. So now the d cos theta upon n into omega upon cos phi. So now it can be written as omega upon n cos theta upon cos phi. Now we know that the sin square theta plus cos square theta, that is equals to 1, or we can write it here, the cos phi equals to 1 minus k sin square phi raised to power 1 by 2. So this is the same. Here the angle will be considered as a phi. This is phi. Now the substitute the value of sin phi from the previous equation. Sin phi is equals to sin theta upon n. So here you can see the omega c is equals to omega upon n into cos theta upon this, and simplify this equation, and now finally we get the value of omega c, that is equals to omega cos theta upon n square minus sin square theta raised to power 1 by 2. So this is the final equation of angular velocity of connecting rod. Thank you.